spend a few slides talking about electric vehicles. They've been mentioned already, and I hope to add a little bit more about that. And then, if I have time, finish with political economy considerations, citing a couple of papers by Steph, and he can correct me if I make a mistake, which is likely. We know that greenhouse gases are important, and transportation is a main contributor. Statistics for the European Union and US, and because the US is a larger country and more automobile dependent and long distance, transportation contributes a somewhat larger share to total economy-wide emissions, and then passenger vehicles account for a significant fraction of the total. Here's a list of 6 local pollutants, and the first 3 are the main ones created by road transportation. Nitrogen oxides, particulate matter, which is particularly bad for human health, and carbon monoxide. Road transport contributes quite a share of those pollutants, specifically or particularly a particulate matter. And part of the reason for that, as I'll indicate, is that the people are close to the vehicles. It's not like aviation where there may be local pollutants, but if they're at 10,000 meters elevation, it doesn't directly affect people. Now, local pollutants have multiple effects. They have an effect on the environment, on vegetation, as well as people. But in the main, the costs are due to human health. And there are various sources indicating that globally it's a significant impact. More than 4 million premature deaths due to air pollution, and then some 1/6 of lower respiratory infections due to the small particulate matter. And the smaller, the worse, because the deeper into the lungs the pollutants go. And as I indicated, road vehicle pollution is bad because people may be just a couple meters away. They're on the sidewalk, and there's a vehicle waiting for the light to turn green. And then people in the vehicles, especially if it's stop-and-go traffic, they can account for more than 10% of the health costs of exposure to the local pollutants. So I want to emphasize the difficulty of designing policies, the whole suite of policies, which do a good job of tackling emissions. And the challenges are much greater for the local pollutants than they are for the CO2. And there's several reasons for that. The first, you have other externalities: traffic congestion, safety, hazards, road damage, noise, barrier effects. And I'll show you a slide, I guess the next slide, indicating that the pollution costs and the greenhouse gas emissions costs combined are a fairly small fraction of the total. So when you're designing policies to tackle greenhouse gas emissions and local pollutants, you should really think about its effects on these other externalities. Otherwise, you're in the world of second best, and you could actually be making things worse rather than better. Second reason is that the agents may not be fully optimizing due to psychological biases or lack of information. And that includes the vehicle manufacturers when they're deciding how quickly to start building electric vehicles, and also how fuel efficient to make their vehicles. Perhaps more important is the imperfection on the consumer side. Do you buy a fuel efficient vehicle? Do you buy an electric vehicle, which has lower operating costs? Evidence indicates, and more so for the United States than Europe, that people are myopic. They tend to discount the benefits from having a more efficient vehicle for 10 or 15 years. They focus on the upfront costs, which are considerably higher for electric vehicles than a comparable internal combustion engine vehicle. And then the public acceptability constraints as well. People are opposed specifically to tolls, but also to increases in taxes. The Gillette-Jones, for example. So the governments, if they want to be realistic, are obliged to that they adopt constrained policies, and that's a further complication. And this is a table, a truncated table from the third edition of the Small Verhoef textbook, 16 years after the second edition, and I was brought in as a third author. And it lists all the costs associated with, well, driving in the United States, and the units of measurement are US 20 $20 per vehicle mile, not per vehicle kilometer. We have variable costs, which are largely borne by individuals, operating cost and fuel. And then the costs which are partially borne by other people, that is their externalities. And then towards the bottom, we have the fixed costs associated with the infrastructure. That's a fairly small fraction. And then the total given in bold type there. And then we can look at the environmental costs, the local and the global, where the global are the greenhouse gas emissions. And the table shows the private average cost, the social average, and so on. And you can see that they're comparable. And that's in the case of the US. In Europe, the local cost may be larger because of higher population density. And if we take the ratio of the environmental cost to the total cost, you can see it's just a few percent. Even with the externality, it's only about 10%. And so the big picture really ought to be taken into account in designing policies targeted at the environment. And what do the health costs depend on? Well, they depend, of course, on the volume of emissions and also the costs of people who are exposed. If you have a local pollutant in the middle of the nowhere, it doesn't really matter, but it does increasingly so the more people who are exposed. Well, the emissions depend, of course, on the engine power, and Yannick Rioux, who's in the audience, has done work with Andre and me, and he can give you the great detail about that. Maintenance costs, of course, if the engine is badly maintained, then it becomes less fuel efficient and the catalytic converters may not work quite as well. And then the temperature, cold starts, for example, are bad for pollution. Speed and acceleration, and I'll show you curves indicating that. The surface of the road, right, there's a lot of silt on the road, then that causes more particulate matter, dust and so on to get kicked up, and that has adverse health effects, even humidity. Then the cost of the emissions depend on, well, where the emissions are relative to the population. And that, of course, depends on wind speed. If you're upwind, you're probably not exposed at all. Depends on the direction, of course, and then the turbulence and how laminar or non-laminar is the airflow. They all have effects. Then there's the built environment. The buildings and other infrastructure affect the direction of the wind. And there's been work done indicating trying to deal with that, but it's very difficult because you really need high-resolution models in order to see how the wind is affected. And of course, it also depends whether someone's in a building or not. If they're in a building, they may be fairly well protected. Population density and proximity, of course, and then the general health of the population. If people have pre-existing health problems, then an increase in pollution is going to cause them perhaps some severe health implications. Speed, of course, affects fuel consumption and the emissions of greenhouse gases. And the way that's tested is via this so-called worldwide harmonized light vehicle test procedure. And it involves operating a vehicle for 30 minutes at varying speeds. And there are 4 parts, from low speed to high speed. The low speed corresponds to driving in the city, and the highest speed would be on the highway, maximum speed about 130, which I think is the maximum speed limit in France. And then the fuel consumption and the emissions of the pollutants are highly speed dependent, and this comes from work by Andre Lefrieux and Blonde. A paper just came out as a working paper, and it shows U-shaped curves for all 4 pollutants. 3 are local pollutants, and then CO2, which is now considered a pollutant as well by the EPA. So all U-shaped, and that means that it's at intermediate speeds where the pollution is lowest, and hence, other things equal, that's the optimal speed to have traffic operate on. And the fact that these curves are convex means that using an average speed is going to cause an underestimate of the emissions. So you have to have models which account for variation in speed, preferably on a small, fine time scale. How many policies are relevant? The answer is quite a large number. And on this slide, I've listed what I call traditional policies, and the ones in blue are policies which are targeted at fuel consumption. And then you can see there's a number of others as well, which will have at least indirect effects on emissions. And then what I call newer policies, and there's a lot of blue there, carbon taxes, tradable emissions permits, etc., electric vehicles, and then subsidies for electric bikes, which are coming to Canada as well as some other countries. So all of these policies, in principle, but not in practice, should be coordinated like a concert. Right? So that's the first best ideal, but for various reasons they're not done. And then some cities have multiple policies. In Paris, for example, there's these four. Perhaps you know of more than that. So here we have a suite of policies. In principle, they should be coordinated, and that may be possible if it's a single level of government which controls those levers. Now let's look briefly at a selection of those policies which are listed in the previous two slides. Vehicle ownership and driving restrictions include quotas on vehicle registration, for example, Singapore and Beijing, daily driving restrictions, traffic calming, speed limits. Speed limits are coming down in cities, including in Vancouver, and more so near schools and other places, down to 30 kilometers an hour. And that causes an increase in emissions if you look back at those U-shaped curves. And then I'll give a little more attention to odd-even license plates because they turned out overall to be a bad policy. Here I've listed four of them. One of the early ones was in Mexico City. Beijing introduced one for the Olympics, a couple of large South American cities, and then a number of Chinese cities. And studies which looked at those, and only one, the one for Beijing, concluded that the policy was successful. In other cases, it was actually worse than doing nothing. In the case of Mexico City, families got two cars, one with an even license plate and one with an odd, and that meant they could continue driving, so that wasn't curtailed. And then one of the two vehicles may be an old, highly polluting vehicle. They look into the details at policy because of unintended consequences ended up being a bad idea. Car-free zones, you see a lot in Europe, and that's partly because the European cities are older, narrow streets, they weren't designed for cars, so they're better suited, and then sprawling, let's say, North American cities. And then some Asian cities developing rapidly are building in car-free zones because they can, right? The infrastructure is flexible and they want to be modern. What are the benefits of car-free zones? Well, they do reduce greenhouse gases, emissions, and noise. And Madrid is an example. Study looking at the effects of the car-free zone in the city center. 14% reduction in carbon dioxide, 38% in nitrogen oxides, which is one where it has adverse health effects. And then smaller fractions, of course, but still non-trivial reductions in the whole city. And then in the long run, if you introduce a car-free zone, the parking that is there can be repurposed. You can take that valuable land and do other things with it, maybe increase vegetation and possibly reduce the urban heat island, something that Steph mentioned just a few minutes ago, which is an environmental related effect. Low emission zones, which allow electric vehicles and I guess the standard 5 or 6 internal combustion engine vehicles in Europe, they can operate in these zones, and there's like 300 of them now operating in Europe. And in Spain, as of this year, all towns with 50,000 or more residents are obliged to implement low emission zones. Study by Wolf in a top economics journal found that they are successful in reducing pollution, but there's an equity dimension, and that issue came up, I think, in the last presentation. Who can afford high cost internal combustion engine vehicles which are environmentally friendly, or electric vehicles? Well, it tends to be richer people. So if you apply subsidies for the purchase or provide electricity at a lower rate than for other applications of electricity, it tends to be the rich who benefit. What about fuel taxes? They've been around for many decades. European Union has been trending towards using them as a Pavlovian tool to address externalities, but as I indicate on this slide, historically they haven't done a good job of that, or they haven't actually tried to implement it that way. So how good is the fuel tax? Well, it's a perfect instrument for internalizing carbon dioxide emissions because the emissions are proportional to the fuel consumption. Right? So you have one tax rate for gasoline and another for diesel fuel. You can't do better than the fuel tax, but not nearly as good for the local pollution for reasons shown in earlier slides. It depends on the speed, it depends on the acceleration, depends on the type of engine, it depends on population exposure, and the weather in principle as well. So the ideal instrument would be dynamic and it'd be differentiated along several dimensions, and that's a tall order to design, let alone implement such an instrument. So Georgina Santos had this paper looking at the fuel taxes in Europe and comparing them with the externalities and finding that the rather weak correlation. So they weren't being used as Pigouvian tax instruments. Then if you look at across Europe and elsewhere, the fuel taxes vary greatly. Right? So they're the sort of the old version of a carbon tax, and they're not coordinated at all, which is inefficient and also unfair. And then if you have big tax differentials between smaller European countries or between states in US or provinces in Canada, then it can induce cross-border shopping or tank tourism. So people will drive perhaps out of the way so they can fill up in a low tax region. And that means more driving, more externalities, more fuel consumption, and more emissions. So coordination across regions and countries is preferred, but again, it's difficult politically. What about the equity effects of fuel taxes? Many studies, dozens of studies, and the results vary. The perception is that the fuel tax is regressive, but Jonas Eliasson has done some fairly recent studies suggesting that the story is nuanced, slightly regressive for rich countries, but progressive for poor countries. And some of the explanations for that came in this co-authored work. Depends on the car ownership rate. In rich countries, most people have cars, and the richer drive them more, but not proportionally to their income. So that's where the regressivity comes in. Whereas in developing countries, the poor people don't have cars. They don't pay the fuel tax. It's the rich who pay it. And so you get a flipping of the distributional effects according to the country. And of course, it depends very much on how the fuel tax revenue is used. Is it dedicated, as it I think is in some countries, but not as it is in the United States, but not in Canada? There's a big difference between those two countries. And then it also depends on whether you live in a city or in the rural areas. Rural areas, people tend to drive a lot more, so they pay more fuel tax, but they're not correspondingly richer. If anything, they're poorer, right? So the city residents tend to benefit. Carbon tax is sort of a modern version of the fuel tax, and it operates exactly that way. In fact, it's added into the fuel tax. That's how it operates in Canada. So it's a good instrument for internalizing greenhouse gas emissions externalities, but not for the local pollution. Tradable permits are, in certain conditions, the absence of uncertainty equivalent to a carbon tax, but not otherwise. And you have the emissions trading system in Europe that was mentioned earlier today. It includes electricity, so the electric vehicles are paying, but so far, direct greenhouse gas emissions for road transport are not included, although they will be according to a plan 2 years hence by a separate emissions trading system. So this is one instance where there's a bias against electric vehicles. And some of the limitations which apply to the fuel tax also apply to the carbon tax and not coordinated across countries. There was a slide shown earlier where some 80% or so of the world's population is affected in one way or another, but it's certainly far from uniform. And then there can be differences within a country according to whether they've implemented a carbon tax or tradable permit. And that is the case in Canada. Quebec has a tradable permit system. It's coordinated with the one in California. All the other provinces have either their provincial specific tax rates or the national tax that the Trudeau government introduced a while ago. And of course, the price of a permit is volatile, depends on what's happening in world oil markets and so on, whereas the fuel taxes are set according to a schedule. So they're constant for, let's say, a year at a time. So you're getting fluctuations there in the stringency of the instrument as far as pricing the fuel. I won't spend much time on this. This is an extract of an OECD paper that I co-authored, and it's looking at the congestion pricing schemes, the 5 big ones which have been implemented. And the bottom row shows the degree to which the tolls are differentiated by the environmental characteristics of the vehicle. And this is an up-to-date table. There's not a lot in that bottom row. And the reason is that initially for London and Stockholm and it was Milan, they had a lot of differentiation. They were treating electric vehicles better, but problems arose. More people bought electric vehicles, so the traffic congestion went up and so on. That what happened in Milan, and changes were made, right? Eliminating the exemptions or reducing the discounts. And in Milan in 2012, they changed the nature of the scheme. Instead of it being targeted at pollution, it was targeted at congestion. So in a sense, it was going backwards as far as the environment is concerned. And so I mentioned this first. No, sorry, London, Stockholm, and Milan. How well have the schemes functioned as far as reducing emissions? So there have been several studies for each of those cities, and indicating that they were successful, various percentage reductions in nitrogen oxides, particulate matter, carbon dioxide. But the benefits were dominated by other things: travel time savings, right, because of less congestion, and reliability improvements, which by some measure is comparable in magnitude to the benefits from the average, that is mean travel time savings. And then there's limitations of the schemes. They're targeted at congestion, and that means they're not targeted at pollution. There'd be quite a difference if you're targeting travel delays versus pollution, because of the dependence on acceleration, vehicle type, and so on. Now, there have been a few studies by German researchers, I think using MATSIM, were able to simulate the emissions of every vehicle in a large city second by second, and charging them according to not only the congestion externality, but also the emissions externality. So it's possible to model that. Is it possible to implement it in practice? I think it'd be very difficult as far as the equipment, and even more so to design something which is politically acceptable. So it's something perhaps in the far future, maybe too far, because we'll have electric vehicles 5 minutes, and then it won't be necessary. Let me skip over the ban on the sale of ACEVs. We know the situation in Europe, and then backsliding in the United Kingdom, and look at the electric vehicles. Many supporting measures, you're probably familiar with them, and implemented now in North America, US and Canada, as well as in Europe. Subsidies for public chargers. Biden administration announced over a year ago a plan to implement 500,000 public chargers. And then the benefits from use: discounted electricity rates in France, exemption from the road maintenance tax, which accounts for quite some percentage of the fuel tax, and then privileges, able to drive on tolled lanes, for example, that internal combustion engine vehicles can't, and then dedicated parking spaces. There are various advantages to electric vehicles, mainly the lower energy cost and the simpler drive it technology, which means lower maintenance and cost. As far as the social benefits, fewer greenhouse gas emissions, and no local pollutants, although there's pollution when the electricity is generated, but there's some disadvantages, and I don't think it's been mentioned so far today. They can accelerate very quickly. You can get a lot of horsepower, and that could mean loss of control. And then they're heavier, maybe 20% heavier, even if the bodies are identical, the electric and the thermic versions, which means slower to brake because there's more mass to slow down. More particulate emissions because the axle loadings are heavier and you get more kicking up of silt on the road. More tire wear, partly because of the greater weight and partly because of the torque. And then the safety externalities, not for the occupants, but for other people. If your vehicle is half a ton heavier and you hit someone, there's going to be more damage. And then damage to the road. And there was a recent study concluding that two comparable vehicles, the electric is causing twice the road damage. That's probably not a problem, except if it's a weak road to begin with thin pavement, but it is a consideration. And Norway, which has eliminated the purchase subsidy for electric vehicles, is now considering a weight-based tax, which would apply to all vehicles, electric or thermic. And then there's various barriers to the adoption of electric vehicles. I think they're all familiar, so I'll skip over that. Then uncertainties about the raw materials, and that's not just lithium, it's also cadmium and manganese and copper and so on. And then, of course, there's international concerns about the supply because it tends to be fairly concentrated in some countries. What about the environmental effects of the EVs? Well, during usage, there's no emissions from the tailpipe, but you are getting emissions from the electricity generation plants. And where that 1 minute, okay. I think I'll have to skip over Steph's work on the public aspects. So the manufacturing costs are considerably higher for electric vehicles because of the heavier batteries, and those the costs involve collecting the raw materials, tearing them out of the earth, so the landscape implications, maybe human rights implications, and then the processes used to create the batteries. And then the end of life, it depends on what's done. Is the material recycled? And I think it can be now about 95%, or put to secondary uses, storing energy to deal with the fact that solar is only available during the day, and electric bicycles, which of course draw much less power. And then this the map shows the emissions from generation of electricity. This is averaged over the day and the mix. France is quite good, 72 grams per kilowatt hour. A few other places in the world are even cleaner, but most of them are worse, and the worst within Europe is Poland, more than 10 times the emissions of carbon dioxide per kilowatt hour. So it depends very much where you're driving, and also it depends on where the batteries are being manufactured. All right, so I'm out of time, so I'll stop there. Thank you.
Okay, thanks a lot for the presentations. I guess there should be quite a couple of questions.
If I may just raise one small remark or suggestion is, whenever you discuss in Europe electric vehicles, electricity production is capped. So the net emission of the electricity used by an electric vehicle is zero, because it will be compensated by another source of emissions that will be reduced. And this is a very important difference between Europe and, I would say, the US, where in most of the US, in some places in the US where you say the marginal power station is a coal power station, then you have to start raising questions about the benefits of an electric vehicle. But I would never do this for Europe. What is still true is that if we imported the electric vehicle from China, with all respect for China, there is not such a cap in China. So the emissions in the production of an electric vehicle coming from China are not zero, while the electric vehicle produced in Europe has net zero emissions.
So
I don't want to...
Right? Huh? Yeah, we discussed this.
Yeah, okay, we discussed this before.
And we've been trying to find information on whether the ETS is working as it should in each country, or is there leakage, and it may be difficult.
I think it works. I think I didn't come across any source which said that it doesn't work. All the electricity producers know this. It's a very important part of the electricity market, and it's driving the benefits of wind power, solar power, whatever. So I think there is no doubt about that. At least I've never seen any serious...
It doesn't cover the internal combustion engine.
No, I think it's an important difference whenever you discuss it. I'm not so much in favor of electric vehicles for other reasons, but I think on that point, I think electric vehicles are a good thing. But okay, not my talk.
About electrical vehicles, you never mentioned fine particles emission, which is a real problem, which is the same about the wheels, the particles from the wheels, the particles from the brakes, and all the particles for the use of the vehicles, even if it's electric. And you never mentioned that kind of emission and pollution emission about these electrical vehicles.
Well, I did mention the silt from the road, and I said it was worse for the electric vehicle because it's heavier. But you're right, the braking, but the brakes are used less frequently with the electric vehicle because they have regenerative braking, and so that's an advantage for the electric vehicle.
One last question.
It's not all models. It's all high quality models, but for the models, the low models, there is like no brakes energy and removing.
I think we'll take a final question from Frank then.
A very short remark on this question on leakage. I did the largest leakage study on largest sample for the EU ETS. I think there is large consensus that there is no leakage regarding to electricity. And on other things like steel or aluminum, there is consensus that leakage today is extremely mild or zero. That doesn't mean that there are costs, because if this car is using a carbon credit, then the steel mill has less and has to start abating.
Cost, yeah.
But it's a reasonably closed system. There is quite a satisfactory outcome there.
But it still matters whether it's Poland or France, right? You're getting the Poles in principle should be paying a higher price for their.
So the kilometer in Poland will then impose much larger reductions on the steel mill than the kilometer in France. And so if you're welfare maximizing and minimizing the cost of the whole system, that difference is still very important. Basically says that Poland has to decarbonize its electricity. Right, but given it's a cap and trade, there is some efficiency mechanism, and probably these Polish installations are going to be replaced by at least gas or something renewable when they're end of life.
And the power plants are emitting local pollutants. They can travel quite some distance.
Oh, yeah, it's very
so there's
bad.
Downstream effects.
Yeah, it's very bad.